Hello, good afternoon.
Good afternoon, ma'am.
Okay, so had your lunch?
Yes, ma'am.
Is it all fine there?
Sorry, ma'am. Could you please repeat?
Is it all fine there? Is everything
Yes, ma'am.
doing
Yes,
good? Okay,
yes, ma'am.
so how was your day?
Yes, ma'am. It's going well.
Okay, so I did your class over at 1:30, isn't it?
Yes, ma'am.
Okay, so shall we go to the unit? Is it fine? Do you have
Yes, ma'am.
any good news to share with me? Any good or bad news to share with me? Anything new?
No, ma'am.
Okay, so let me go. Okay, I'm going to share my screen. Is it okay?
Yes, ma'am.
So yeah, we were discussing about probability, isn't it? The chance of occurrence of an uncertain event, isn't it? So I asked you to go through the 26.2 exercise. Check your progress 26.2. Or did you do so?
Yes, ma'am. It's completed.
It was fine. You got the answers there.
Yes, ma'am.
Are you getting confused in any part?
No, ma'am.
Okay, then will you please explain the fourth question for me?
Okay, ma'am.
Okay.
An integer is chosen between 0 and 20. What is the probability that this chosen integer is a prime number?
Yeah.
So we have a set of integers between 0 and 20. So we have to exclude 0 and 20. And
Yeah.
then we have to look at all the prime numbers which are available.
Yeah.
And then, so the prime numbers which are available um, between 0 and 20 are 2, 3, 5, 7, 11, 13, 17, and 19.
Yeah. So we
So these
have
are the prime
eight.
numbers
Yeah.
available.
So we have up to eight possible outcomes. And what are the total
Yes, ma'am.
outcomes here? Total number of outcomes.
Um, Ma'am, the total number of outcomes are 19.
Right. So the probability will be,
8 by 19.
yeah, very good. So you got it, isn't it? So you were
Yes,
you
ma'am.
are you are thorough with this exercise part, isn't it?
Yes, ma'am.
Okay. So let me go to the 26.3. Yeah, we are moving on
Okay,
to
yes, ma'am.
more about probability today. So, yeah, probability has many interesting properties. Today we are going to study, we are going something deeper into it, okay? So, first, in example 20.6 above, that is example of, yeah, a die is thrown once. What's the probability of getting a number less than 7 or greater than 7? Yeah. So, I think we are going to deal with, yeah, impossible event and sure event. Even E is sure to occur since every number on a die is always less than 7. The same thing that we discussed in the last class, isn't it? When we roll
Yes,
a
ma'am.
dice, we have only two, they have given only two options there, either to get a number less than 7 or greater than 7. We, less than 7, we know that it's a sure event. If we got any number, it will be surely less than 7, isn't it?
Yes, ma'am.
Yeah. So it's a sure event. We can just confirm the probability by 1. That is 6 by 6 equal to 1, isn't it? So
Yes, ma'am.
even f is impossible to occur since no number on a die is greater than 7. The second even f was getting a number greater than 7. Is it possible to get a number greater than 7 when we roll a die?
No, ma'am.
So it's an impossible event. It's not at all going to happen, isn't it? Such an event which is impossible to occur is called an impossible event. Probability of an impossible event is always taken as 0 because 0 by 6 it becomes 0 itself, isn't it? From
Yes,
the
ma'am.
definition of probability of an even E, P of E cannot be greater than 1. Isn't it? Probability will always be in the form of a fraction. It cannot be greater than a whole number.
Yes, ma'am.
Okay.
It's always between 0 and 1.
Yeah, it's between 0 and 1. Since numerator being the number of outcomes favorable to E cannot be greater than the denominator. Also, it will be always in a proper fraction form. That means numerator will be always less as compared to the
Yes, ma'am.
denominator. Both the numerator and denominator are natural numbers. So P of E cannot be negative. There are no chances of negative integers to come as the values of probability here. Okay.
Yes, ma'am.
So they have given us P of E will always be between 0 and 1. So shall we move to the observations?
Yes, ma'am.
Yeah, when we are tossing a coin, events like getting a head and getting a tail are elementary events. We know because we have only two options there. Just to get a head,
Yes, ma'am.
either to get a head or to get a tail. So if we add both the elementary events, we will get the answer at the total probability. That's one. 1 by 2 is
Yes,
2.
ma'am.
These are fine. Similarly, when we take the rolling of a dice, we know the probability of getting one third is 1 by 6, isn't it?
Yes, ma'am.
So what's the probability of getting two third?
Ma'am, 1/6.
Yeah, 3,
1/6.
4,
1/6.
5 and 6 also same 1 by 6. So if we are supposed to
Yes,
add
ma'am.
1 by 6 plus 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 1 by 6, since they are like fractions, we just add the numerators and put the same denominator there. That means 6 by 6 is equal to 1, isn't it? So the
Yes,
total
ma'am.
probability is always 1. So some of the probabilities of experiment is 1, yeah. Probability of getting 3 plus probability of getting a number, yeah. That is, what is the probability of getting 3 when we roll a dice?
Ma'am, 1/6.
So, how much?
1/6.
Yeah. So, what's the probability of getting a number other than 3?
Ma'am, 5/6.
Yeah. So, what's 1 by 6 plus 5 by 6?
Ma'am, 6/6, which is equal to 1.
Yeah, that means the probability of getting 3 plus probability of getting a number other than 3 is 1. That is, P of E and P of E dash is equal to 1. That means probability of getting head, and when we add the probability of getting head with a probability of getting other than head, we will get the total probability there. That is 1. Okay.
Yes, ma'am.
So P of E plus P of not E. P of an event plus P of not that event will be always 1. If we take the sum, if we sum up both the events, we will get the answer as 1. Total probability is 1. Okay.
Yes, ma'am.
So it will be clear too when we go to the example parts. Even E is called complement of the even E. That means that E dash we usually represent them as complementary event. Okay. That is, probability of getting 3 when we roll a dice is 1 by 6, isn't it? And other than 3, we will just represent that event as complementary event. Okay.
Yes, ma'am.
If the one is elementary event, the other will be complementary event. Because we are just taking the swiping off the all remaining part. Just excluding that 3, we are just swiping all the other parts, isn't it?
Yes, ma'am.
Okay. So, yeah. If P of E equal to 2 by 7, what's the probability of not E? We know P of E plus P of not E is equal to 1. So, here
1.
we should do 1 minus 2 by 7, isn't it?
Yes, ma'am.
Okay. So, let me give a question to you. Yeah, the same question of the tree. I don't want to repeat it. Okay, shall we go to the card question? Will you please read it?
Yes, ma'am. A card is drawn at random from a well shuffled deck of 52 cards. Find the probability that this card is a face card.
Okay. So from a well shuffled deck of 52 cards, you are supposed to draw a card. And they are asked us to find the probability of getting the taken. The card you took is a face card. So how many face
Yes,
cards
ma'am.
are there in a deck of cards?
Ma'am, 3.
In a deck of cards,
Ma'am, 12.
12, isn't it? Yeah, we have 3 from the red heart, 3 from the red diamond, 3 from the black spade, 3 from the black club. That king, ace, and
Yes, ma'am.
king, queen, and ace, isn't it? So, yeah, we have up to 12 face cards in a deck of cards. So the probability will be 12 by 52, isn't it? So if
Yes,
we
ma'am.
if we just solve it, we will get the answer that is 3 by 30. So let me ask you a thing. Will you please find the probability of getting a card other than face, getting something other than a face card from a deck of well shuffled deck of 52 cards? Did you get my question?
Yes, ma'am. Ma'am, the probability would be 40 by 52.
40 by 52. Yeah, your answer is correct. So if we took up the sum of 12 by 52 plus 40 by 52, we will get the answer is
52 by 52,
yeah,
which
that
equals to
is
1.
equals 1. Yeah. So I think it's clear to say I'm not going into one not to explain this, okay?
Yes, ma'am.
A coin is tossed 2 times. What's probability of getting a head each time? So a coin is tossed, the same coin is tossed 2 times, okay? So let us write heads for head and tail for tail in this experiment. Yeah, the possible outcomes will be we can get head 2 times, we can get a head and a tail, we can get a tail and head, we can get two tails at a time, isn't it? So
Yes, ma'am.
the possible outcomes are four. What is the
Yes, ma'am.
probability of getting a head each time? Each time we should get head.
Ma'am,
What's the probability of getting a head each time? That means both the times you should get head itself. So what's the probability
ma'am,
here?
1 by 4. 1 by
Yeah,
4.
because we have only one option there, HH. So 1 by
Yes,
4,
ma'am.
isn't it? And the possible outcomes is 4. So, okay. 10 defective rings are accidentally mixed with 100 good ones in a lot. It's not possible to just look at a ring and tell whether or it not it is defective. One ring is drawn at random from this lot. What's the probability of this ring to be a good one? So 10 defective rings are just mixed up with 100 good ones. Okay, so actually you have 100 good rings and 10 of them mixed with a defective. 10 more is added which gets defective, which is defective. So what's the total
Yes,
outcome
ma'am.
there? Total how many? What is the possible
Ma'am,
outcomes?
100 plus 10, 110.
Yeah, because that's those 100 good ones just mixed up with 10 more defective ones, isn't it? So, what's the
Yes, ma'am.
probability that the one you choose will be a defective one? What's the probability that the one you choose will be defective?
Ma'am, 10 by 110.
Yeah, so it will be 1 by 11, isn't it?
Yes, ma'am.
Okay, so so what will be the probability that the ring you choose is a good one?
Ma'am, 100 by 110.
Yeah, 100 by 110, 10 by 11. Okay, so if we add 10 by 11 plus that 1 by 11, we will get the answer as 11 by 11 equal to 1, isn't it?
Yes, ma'am.
Okay. Do you want me to discuss this die question? Because we just I just explained all this part 2 last day, isn't it?
Yes, ma'am. This was already completed yesterday.
Yeah, so I'm going to uh if you got time, you may please go through this 26.3, okay?
Okay, ma'am.
Just to check your progress. Okay, let me discuss a question from here. A bag contains 15 white balls and 10 blue balls. A ball is drawn at random from the bag. What's the probability of drawing a ball of not blue color? Second one, a ball not of white color. Okay, so Sarek has got a bag with you and it has a lot of balls in it. About 15 white balls and 10 blue balls. So you just drawn a ball at random from the bag. without looking the color and all. You just drawn
Yes,
a
ma'am.
ball at random. So what's probability of getting a ball of not blue color? So we will get a
Ma'am,
ball of white
fifth.
color.
Yes, ma'am. 15 by 25.
Yeah. So what about a ball not of white color?
Ma'am, 10 by 25.
Yeah, very good. So I'm just leaving that page, okay? So shall we let it sum up? We have just reached the end of this part.
Yes, ma'am.
Do you want me to discuss any other questions?
No, ma'am.
I think from the last day we just go through all this and you're fine with it, isn't it?
Yes, ma'am.
Okay. So just sum up this chapter. You may please go through let us sum up points. You may please read it.
Okay, ma'am. Let us sum up. A random experiment is one which has more than one outcomes and whose outcome is not exactly predictable in advance before performing the experiment.
Yeah.
One or more outcomes of an experiment constitute an event.
Yes.
An event having only one outcome of the experiment is called an elementary event.
Yes.
Probability of an event i- P E is defined
P
as
of E. P
PE
of E.
P of
Probability
E
of an even E. Or we can
is
just
equal
say it as
to,
P of E.
yes, ma'am, number of outcomes favorable to E divided by number of all possible outcomes of the experiment when the outcomes are equally likely.
Okay.
0 is less than probability of event.
Less than or equal to probability of even E less than or equal small. Okay.
Yes, ma'am.
Will you please repeat it?
0 is less than or equal to probability of event or less than or equal to 1.
Yeah.
If probability of event is equal to 0, E is called an impossible event. If probability of an event is equal to 1, E is called a sure or a certain event.
Okay.
The sum of all the sum of the probabilities of all elementary events of an experiment is 1.
Yes.
Probability of an event plus probability of of not an event is equal to 1, where E and not E are complementary events.
Okay. So you got that?
Yes, ma'am.
Okay. So shall we discuss one or two questions from the terminal part, terminal exercise part? Or is it fine for you?
Yes, ma'am.
Do you want me to discuss or is it fine?
Ma'am, it's fine. It's
Okay.
this chapter has been completed.
Okay. So shall we move to the next part? Okay,
Yes,
let me
ma'am.
ask you a question too. In a simultaneous toss of two coins, probability of getting one head and one tail is fast. Make it fast. In a simultaneous toss of two coins, probability of getting one head and one tail is.
Ma'am, 1 by 4.
Will you please read the question once more? In a simultaneous toss of two coins, that means I'm tossing two coins at a time. Okay, the probability of getting one head and one tail. It is HT as well as TH, isn't it? We have two chances there. We have two
Yes,
favorable
ma'am.
outcomes. It can be head
Yes,
in the
ma'am.
first coin and tail in the second coin. Similarly, it can be tail in the first coin and head in the second coin. Did you get me?
Yes, ma'am.
So
So
it will
one by
be,
two.
yeah, 2 by 4 equal to 1 by 2. Is it okay for you, dear? Are you getting confused?
No, ma'am.
Is it fine?
Yes, ma'am.
But when you're making small mistakes, I'm a little bit terrified. Do you want me to explain the concept once more in one note? If you want, I will draw the whole concept and explain to you once more.
No, ma'am.
Okay. So let me ask one more question to you. A card is drawn from a well shuffled deck of 52 cards. What's the probability that this card is a face card or red color? Mm, yeah. Okay, Sanang. Let me explain the thing to you once more. What's today? Today's date? Okay.
Ma'am, 19.
Yeah. Thank you, dear. So they have said that from a well shuffled deck of 52 cards, you are supposed to draw one from it. Okay. And what's the probability of that should be a red colored face card. So let me show that deck of cards to you once more. Yeah. So we know there are three face cards from the heart red and three face cards from the diamond red, isn't it? King, queen, and
Yes,
ace.
ma'am.
So total of
Yes,
how
ma'am.
many red face cards are in a deck of shuffle the cards?
Ma'am, 6 red
Yeah,
face cards.
three from this part as well as three from this part, isn't it? So we can write here as number of favorable outcome equal to 6. So what's the number of total outcome or possible outcomes?
Ma'am,
Can be
26.
52, isn't it? Because we are just drawing a card from that well shuffled deck of 52 cards. So each card have got a probability to come to draw, isn't it?
Yes, ma'am.
So the probability will be 6 by 52, or we can just say it as 3 by 26. Is it 5?
Yes, ma'am.
Are you getting confused?
No, ma'am.
Then let me ask a question from this part to you.
Okay, ma'am.
Okay. So here we have got a deck of 52 cards, and what's probability of getting a card number 10 from this deck of 52 cards?
Ma'am, 4 by 52.
Yeah, when we solve it, it will become 1 by 13, isn't it?
Yes, ma'am.
Okay. So what's the probability of getting a card other than queen from a deck of 52 cards? What's the probability of getting a card other than queen from a deck of well shuffled 52 cards?
Ma'am, 48 by 52.
Yeah, because we know the probability of getting queen is only 4 though. So just 52 minus 4, we will get the answer as 48 by 52. So when we cancel it, what's the answer? 24 by 26, 12 by 13, isn't it?
Yes, ma'am.
Is it okay for you?
Yes, ma'am.
So, so let me just a minute here.